Hey, Skullmeat. Stormlock, if you're looking for cute emerald, wait, let me actually get close to the microphone. If you're looking for cute emerald, cute MA voice, sorry to disappoint. If get this, feel free to stay. Right now, I am working on a problem set that's pretty late, but the student the person that's grading it seems to be pretty okay with slightly, late assignments. So yeah, we're gonna try to get that credit. It's probably a little too close for the mic, actually. Yeah. So yeah, that's all there is. That's all this is. I have 2 parts left. It's a 6-part problem, and I only have the last 2 parts. And there's actually a solution manual. So I'm gonna kind of just it's a little unfair, but I'm gonna work off the solution manual. It's actually somewhat fine because the derivations that we did use a different kind of pathway than the textbook. So we, it's designed. I thought it was a smartly designed problem set, right? It's designed so that you can get help, if you need, but you can't just copy the solutions without kind of giving it away because your derivations will be different. Or they'll be slightly different. They'll end up with the same answer, but they'll be slightly different. So in college, yeah. I'm this is the last class I need to, so I'm only taking one class this semester, but it's the one last class I need to get my degree, so then I'll have my bachelor's, yay. I gotta actually pass first though, so yeah. Right, anyway, so yeah. Yeah, I actually have to I have to meet with some people to figure out what I'm gonna do after college, but or after I get my degree, but yeah, taking class for. So I'm a physics major. So that's probably the fastest way to say it. I'm a physics major, so I needed a upper division physics elective course. That was the last requirement that I needed. So I'm taking second semester electromagnetism and optics, just because. And if you're somewhat familiar, then you'll know that the textbook that most people use is Griffith's Intro to, I think it's Electrodynamics. Is that what the textbook is called? Let me see. I kind of forgot what the textbook is actually called. Sorry, let me look it up really quick. I have the digital copy right here. Oh fuck, everything crashed. Sorry, one sec. There we go. Yeah, it's Griffith's Intro to Electrodynamics. Yeah. Gotta sleep? Oh yeah, sounds good. Thanks for popping by. Yeah, I'm gonna work hard. I gotta work hard, but I'm hanging in there. But yeah, thanks for popping by, and I guess yeah, go sleep. important to get rest. Yeah, thanks for coming by. Let's see. What was I doing? Right. Dr. Follow. Oh, great, thanks. Yeah, sorry, I don't have any of all the like notifications set up, so sorry, I can't actually see it. But thanks for the follow. Yeah. See you tomorrow. I mean, no pressure though. I mean, all I'm gonna be doing tomorrow is studying probably as well anyway. So yeah, feel free to pop by whenever you wanna. You're not gonna miss anything if it's tomorrow or next week or next year. But anyway, yeah, thanks for coming by. Yeah, good night. Let's go to Donkey Dong. Oh wait, did I mess up the? No, I'm on screen. Yeah. K-Stel, welcome back. It's been a hot minute. Hasn't been too long, but it's been a bit. I got more problem sets to solve, so we're gonna do that. Yeah. All right. So, where's the food stream? I already ate today, unfortunately. Yeah. I can do a hydrate though. Yeah. Although, unfortunately, I'm using Streamlabs right now to stream, or not Streamlabs. I'm using Restream to stream. So the Frankerface emotes don't actually show up on my end, unfortunately. Yeah. Add some water. There we go. Yeah, we'll get it all fixed up at some point. I just, it's hard to, take time away from, studying and research to optimize the stream, right? It's a little hard to justify. But one of these days, once I finish classes and once I get everything sorted out, maybe I'll, yeah. Alright, so anyway, so we found T-ret. So this is the time in the past at which the particle is sending EM news such that it affects the particle at the present time, right? And I guess we got that by matching the distance traveled by the EM news to the position function of the particles, or yeah, of the particle. Yeah. Okay. So we have the time, and then what do we need? Sorry, so these. Okay, I need to turn off this music. Take this off too. All right, so right, so this is the position function. No, it's not. X equals CT minus T sub R, which is, or we know T sub R is equal to. Is that what they do? So then. And then you take the time derivative of that, I guess. Okay, yes. Right. So then. Negative b squared 2ct. No, I'm missing it. Oh, shit. What is that? Hmm. So from 10.20 equals here x and here dark time t0, which is c squared 2 squared minus b squared over 2 c squared d for q1 equals gravity versus d c d. Okay. So x of 喋れね。Oh, let me open a door. Ow.ちょっと最初に水汲もう。Where's my bowl of some water. Yeah, what is the issue here? So they get 2ct squared minus ct, or c squared 2. Oh, there is a 2. Fuck. Yeah. So it's c squared t squared minus b squared all over 2ct. Okay. And this is the x vector, which I have labeled as I guess my lone nomenclature's all over the place. Turn back on. Turn that back on. Okay. Okay, yeah, let me fix all my nomenclature first. So we have the setup. We have the function of, or the we have the position of the particle, x a function of t, because it's only moving in the x-axis. It's hyperbolic, and that's why it's this form. So it makes sense that if we were to plug in t ret into the function, it spits out whatever the position in the x-axis of the particle was at that time t ret, which is the time at which the particle is influencing, or the time at which the moving particle is influencing the field point that we're looking at. Okay. And then I guess what I should also say is that so I guess what I should say is that I already say here, yeah. The w vector, which is usually our position vector, is actually the x of t function in the x hat direction, because I don't think we ever actually specify what direction that's in. And then that's also just due to the geometry of the question, is equal to the script r vector. Is that true? Sleepover. Well, no, I think you should get sleep if you can, but I mean, yeah. I mean, I would go to sleep if I could. I'm honestly really tired today. But yeah. Let's see. Sorry, I'm a little confused. So yeah, because we're at the origin, so r equals. Let me put that in my head. So script r is usually r minus the w vector, but in this case the r vector is 0, so... Oh, yeah. Yeah. So then it should be negative w.
Are you asking chat for help on your homework?
Well, I'd like to. I used to have it set up so that my iPad screen was on the stream.
Oh, yeah.
But sometimes I'd get notifications.
Oh, yeah.
And usually it blocks them. Actually, AirPlay's pretty smart about blocking it, but every once in a while I'll pull down like the, what do you call it, like the status bar or with the notification bar, and that doesn't get blocked. Like, so this doesn't get blocked, but you know like how it'll float and like put a notification up here? That does get blocked properly. So if I subconsciously look through my notifications really quickly to be like, oh, what was that? And I just, then that'll show up, that would show up on screens or on stream. So, but otherwise, yeah, it's a little hard to get help, Yeah, I mean, I don't know. Can you do this setup in your head?
Fuck yeah. No.
Oh no, and actually this I guess should be fine because it's the typical example. It's when the yeah, but so what's up? Okay.
Nothing.
Yeah.
Just gonna go with my sister to eat something.
Oh, they're still in town.
They're in town until Monday.
Okay, that's good. Alright, so it sucks that it's raining, right?
It's not raining.
Or I guess it was raining earlier today, but it kind of sucks that they came by right when the weather turned a little sideways. Yeah, I mean, I guess we were long due for rain, so I guess it's good, but kind of sucked trying to eat lunch outside today.
Yeah.
A little too cold.
We're trying to.
Yeah. The thing is, I was gonna buy like a camping chair at Daiso, like the
The
little ones. I was like, shit, I should have bought one. Because
yeah.
the thing is, because I got this bag at Daiso as well, right? It fits about in this size. The nearest Daiso? Shit. The one that I usually go to. No, there's one in, is it El Cerrito or?
Okay.
I mean, because
we can go there Saturday or something.
Oh yeah, totally. Let's do it. It's good because they just stocked, like all the shelves are stocked back up. Just recently. So
we can check for the Great Fancy.
They don't have any. Sorry. It has to be range 99.
Yeah.
I guess, yeah. But yeah. Although I actually just recently did a Daiso run, so I don't necessarily need anything immediately. But if you need something, yeah, I might actually buy another camping chair. I have one at home. It's so useful. Yeah. Yeah. But anyway, you said you were gonna grab dinner with the family then? Sounds good. Yeah, so anyway, so script R, that makes sense. There should be a sign difference. So script R is R, a regular R vector minus W.
You said you can't take this one. Fine, okay, I'll just walk. That's fine. I haven't walked it before. So. tomorrow.
Wait, what happened?
My sister's gonna pick me up. And she's gonna drive me. And she said she's
Oh, your bicycle's gonna get stuck here.
It's fine. I'll just walk. I
Yeah,
don't
it's
prefer it,
like-
but whatever.
Yeah. I forgot, how far did you say you were?
I'm not that far. It's
Oh,
like
okay.
15-minute walk. I'm just lazy. I just want to get.
Yeah, well, the
fast.
problem is it's probably uphill, isn't it? Or do you live uphill?
No, I
or-
live down.
Live downhill? Okay. So it is uphill then.
Honestly, biking's worse. Walking's
Yeah.
not that bad. You can just
Yeah.
go slow.
Yeah.
I'll probably just go up first or something.
That's probably safest, isn't it? Yeah.
It's probably safer to go through campus. Just walk up campus.
Oh, I mean, oh, you meant like Hearst up, like, oh, I see. Okay.
I go up Hearst, like, at the intersection of.
I thought you meant like, wait, where, which way do you, are you down like,
So I go on Shattuck, and then I go up Hearst. That's my route in the morning.
oh, right, because the bicycle path. Or,
There is a bicycle path on Hearst, but not in Shattuck. I just kind of
right, well,
balls out. on it.
yeah.
Okay, you should go.
No, it's good. Technically this is already overdue, but you know, he'll accept it, so I just have to have it done probably soon. Yeah. Yeah, can we actually do that like Daiso Ranch 99 run on the weekend though? That'd really help.
Yeah. Saturday.
Dude, let's stockpile on more drinks, man. Like, actually, let's put the Calpico in the fridge.
Would you be good for the morning? Because I might have some.
Yeah, totally. Well, I mean, how morning? As long as it's past like 9 o'clock, I'm game. Yeah.
Yeah.
I don't really want to wake up any earlier than that.
Yeah. I might have some stuff to do during the day tomorrow or Saturday. I don't know.
Oh, do you want to do it Sunday then? Or
Sunday? No, Sunday's not good.
oh, good. Actually, wait. Didn't you say your family's here until like next Monday?
Yeah, just my sister.
Oh, okay.
Saturday she's busy, but
Hmm.
some friends were going to play basketball.
Hmm.
But
Cool.
I don't know what time. So let me figure that out and then I'll tell
Oh
you.
yeah, totally.
Okay. She's probably going to yell at me if I'm outside.
Can't you just like drop a pin to tell you where she is right now?
Oh, she's literally.
Okay. Alright, yeah, sounds good.
Alright.
Yeah,
See
alright,
ya.
have fun. So yeah, scriptar is negative x. So scriptar. What did I just calculate? What am I trying to calculate? I'm a little confused now. Oops. Okay, right now back to work. Right. Right. So what information do I really need? I guess we have the setup up to here. It's just why they do this. So yeah, let's just rethink. Okay. So the moving particle emits EM information, well, in vacuum, and the moving particle emits EM information at the speed of light. So, so if we consider a arbitrary given field point, or an arbitrary point in space, the the field or the EM field at that point is determined by whatever EM information happens to arrive at the field point at the time in question that we're looking at, right? Which is why we care about where the particle that's moving was, because depending on where it was, or where it was determines what field we measure at our point in question now. Right. So we define the position of the particle as W, but in the question they define it as X. So first translate that. So yeah, W vector equals X function X hat, because we're restricting, or the problem restricts the particle to the X axis. And then normally we also define script R, which is the distance from the field point that we're measuring to the particle, which is R minus W, which is in this case R is 0, because the field point that we're measuring from, or measuring at, is the origin. So then script R is just the difference vector of the origin and the position vector, which is basically the opposite of the position vector, so that checks out. Okay. And then we can say that script R vector squared, here we go. Script R vector squared is then just the magnitude of the position function. Okay. Hi. Yes. And then the vector, yeah, okay. The unit vector's dot, yeah. Well, so that should say script R, the magnitude of that vector is just the X function squared. Yes. Okay, cool. And then what we want to say is that we want to solve for T-ret, the time in the past that the information was emitted at, and then eventually plug it into the position function so that we can figure out where the particle has to be in order to influence the field point or the origin at the current time. Right, so let's see. Yeah, so the game plan is we want to find T-ret. How do I want to start that? I guess, yeah, we want T-ret in terms of T. Let's start with that. Want T-ret in terms of T. Cool. And what information do we have? We have the position function, which is x of t, and we also have we also know that this is vacuum. Let's see, yeah, so vacuum, which implies that script R script R, one of these distances is essentially speed of light times time, because that gives you the distance that the information travels. Can I just say that's x of t? I feel like I'm doing something wrong. Well, then let's just write down what we know. Okay, this vacuum, so that means that EM news travels a distance c t minus t ret. Yeah, that's just some distance it travels. So we know that. And then we also know that I guess we also know where the particle was. Let's see. Particle at time t ret is equal to or is at x of t ret, which is equal to square root b squared plus c squared t ret squared. Okay. Then what can I say about those? I guess those should Yeah. So yeah, that's what we think about it as. We're just on the x-axis, so yeah. So we're on the x-axis. X of t ret is saying the particle was here or something. Yeah. Particle was here. And sometime later, I don't know. That doesn't actually matter. So the particle was here at some time in the past. So like t before. And then what c t minus t ret is saying is this is how far the information traveled in order to hit the origin in order to hit the origin at the right time. And those are the same quantity. So then we can just set those equals. Actually, yeah. Okay. Cool. Yes. Okay. So then we can say probably by observation, just draw one axis. Monitor C, welcome back. How's it going? For the record, today's not like a rush to finish assignments day. It's more of a, the faster I get this done, the faster I can work on the next problem set day. So I mean, time's counting down. I think like 3 hours and 3 days and 3 hours left to finish the next problem set, which is another it's a 2 problem set with 8 parts again. So okay, but anyway, let's say that here this is x of t ret, for example. So we'll say this is x of t ret. This is location, and let's just do it in pink or something. We'll say so let's just do by magnitude, because it'll end up being the same, because it's just one axis. Just sign difference. This is c t minus t ret. And then we say by observation, these are the same. So therefore we can say that c t minus t ret is equal to square root b squared plus c squared t ret squared. Misfortune never comes along. Oh, great, what happened now? Cool. And then we can just probably square both sides. So that says c squared t minus t ret quantity squared equals b squared plus c squared t ret squared. So that's c squared t squared minus 2tt ret plus t ret squared equals b squared plus c squared t ret squared. So c squared t squared minus 2c squared t ret plus t ret squared equals b squared c plus c squared t ret squared. Oh, this is c squared. C squared t ret squared. So then these two cancel. And we can say c squared t squared minus b squared equals 2c squared t ret. Wait, what? I have an extra c. Or no. This isn't the position yet. This is just what time in the past it is. So t ret equals c squared t squared minus b squared. B not beta, yeah. 2c squared t. Cool. So now we know if we're looking at the origin at time t, we have a function to determine at what time in the past t ret the particle must have been or must have emitted EM news on this hyperbolic trajectory to produce a EM field at the origin. Yeah. Okay. Cool. So we have t ret. What now? We want to find the force, which means we need to know the velocity, which means we need to know the position first. So, need to know velocity, need to know. Geez, Montmorency, was it that bad? I guess it was just so bad that it shouldn't even be uttered. Wow. Yeah, hang in there, dude. Need to know position. Cool. So then x of t ret, which we said was square root b squared plus c squared t squared. Do I really want to shove all this in here? I guess, but also... Yeah, I should, maybe not. And I guess this is where we can rely on the solutions, but it's equal to this. But also, we also just said that it's also equal to ct minus t ret. So we'll use that instead and say that x of t ret is actually equal to ct minus t ret, which is equal to ct minus and then c squared t squared minus b squared over 2c squared t, which equals 2c squared t squared over 2c squared t minus c squared t squared minus b squared over 2c squared. Yeah, okay, geez. Yeah, hang in there, I guess. Yeah, life sucks. Nope. Not really sure what else to say. Let's see, c squared t, or ct. So now we have the sum of those. Yeah. And this is plus. So c squared t squared plus b squared over 2ct is the position of the particle at that past time for it to influence the current, or the particle at current time t. Yeah. Yeah. And then we can take the derivative of this for the position, I think. Yeah. We're really at x? Huh? Alright, let me just try to... Okay, so... velocity, we'll just do the... is d dt of x of t ret, which equals c squared t squared plus b squared over 2ct, which is actually c squared t squared plus b squared quantity times 2ct inverse. So then that's equal to c squared t squared plus b squared times the derivative of 2ct inverse plus 2ct inverse d dt c squared t squared plus b squared. Negative 1 to ct times time derivative of 2ct, which gives us 2c. Or actually, wait, no. Negative 1, then to negative 2. Okay. So then that's negative 2c over 2ct quantity squared times c squared t squared plus b squared plus, and then we have a 1 over 2ct time derivative of that, which is just 2c squared t plus 0. Or c cubed t squared. Okay, yeah. And we have a term like that. So now you end up with positive 2c cubed t squared minus 2cb squared over 2ct quantity squared. Is that what they get? They get v of t is equal to 1/2 2c t squared b squared plus ct square root. What did I mess up? I guess the main thing is it's not clear if it's the derivative. Okay, fine, we'll do it. The low d high, high d low thing. And I probably just messed up the algebra somewhere. Quotient rule. Derivative. This is low, so 2ct, and then d high, c squared t squared plus b squared, plus high, c squared t squared plus b squared, d low, dt, 2ct, And then you square the bottom 2ct squared. Yeah, I'm pretty sure I did it right. Pretty sure I did it right. 2c squared t plus 0 plus c squared t squared plus b squared 2c all over 2c t quantity squared equals dx dt or dx dt or dx t rad dt. I don't see where this square root is supposed to come from. Unless I just totally don't do it, right? Maybe I already have x of t. Maybe I just take the derivative of that. But then why did I find x of t rad earlier? So you got them on. Well, I mean, that's kind of the idea, right? Rain or shine. I feel like the only time I wouldn't be streaming is if somehow all methods of internet connections were severed. Well, that or I have a headache, right? Yeah, it's either the world ending or I have a headache. One of those will cause the stream to get interrupted. Yeah. But jokes aside, I don't really get why I did that. Because if that's all I needed, then why couldn't I just say x of t is equal to square root b squared plus c squared t ret squared? Yeah, and then just take the time derivative of that, or x of t. Yeah, no, not even t rat. Why couldn't I just say this and then just say, so it's time derivative of b squared plus c squared t squared, or 1/2, which turns into 1/2 b squared plus c squared t squared, negative 1/2 times time derivative of the bottom, which is b squared plus c squared t squared, which is, or time derivative of the content, which is 0 plus 2c squared t. Yeah, that's literally what we got. What was the point of, I don't know. Right. So then dx of t dt is indeed 1/2 2c squared t over square root b squared plus c squared t squared. And they argue that this is equal to c squared t over x of t, which it is. So then we can say, if we just define this as velocity, then v of t is equal to c squared t over x of t, which equals or oh no, that's it. So therefore, v of t ret is equal to c squared t ret over x of t ret. And maybe that was the point. And we just shove everything into there, I guess. Yeah, it looks like what. Okay. Then I wouldn't have done that in that order. I would have done the velocity calculation first, and then I would have done the position calculation as a separate thing. Yeah. Yeah. So essentially, we look at that, we say, find v of t ret and plug in. Cool. Then plug in. So first, v of t ret. See, this is the issue I think with a lot of books. I mean, I guess it's a solution manual, so you shouldn't really expect all that much from it. But it's like, why was I doing all these calculations at first? Really, like the order of operations is, we have a form for the electric field. It has velocity and then constants, and then okay, there's a few other things in there. So then, it should be then, it should point to that first and then say, okay, that's why we're doing these calculations. Yeah. All right. So, actually, so we need, or I guess we'll say plan is find script r hat square, or no, script r. Yeah, script r magnitude squared. And velocity as evaluated both for t ret. Then plug in to find e. Cool. So let's do it in this order because I already know what's going on now. V of t ret. Okay. And then that's all these calculations. And no space. then we just say that implies that v of t ret is equal to c squared t ret over x t ret. Cool. So that motivates us in learning what, or motivates us to find x of t ret. Cool. We can do both of those. So, yeah. So then we do this, and we find t ret. There. And this is the great thing about the, taking or doing problem sets on the iPad, right? You can just move around your notes to make them make more sense. Someone called this cheating at one point, and I'm like, what do you mean cheating? Well, actually, no, they were calling cheating the fact that you can record, like on Notability, that you can record lectures as you're writing, and then it like links your handwriting to the timestamp, or the timestamp of the handwriting to the recording. And he was calling that cheating, and I was like, I mean, I guess if you say so. I mean, you still gotta, learn the material. I don't know. Cool. So we did those, and then okay. So that gives us that gives us v of t ret. Now we have all the components for that. Alright, so t ret is this big guy, and x of t ret is this other big guy. And it's a sum of squares. Cool. I'll take out. So it's c squared, t squared, quantity squared, minus b squared, quantity squared, over, or times c. And then I guess you could do I guess 4c cubed t squared, which you could just call then the top. Is it actually to the fourth? No. Oh, it's inverse. It's inverse. It's inverse. Okay. X is inverse, so yeah. There. Cool. So you end up with 2c cubed t times quantity c squared t squared minus b squared over 2c squared t c squared t squared minus b or plus b squared. So then you end up with just c times quantity c squared t squared minus b squared divided by quantity c squared t squared plus b squared. Yeah. Yes. Yes. Cool. That is velocity at the retarded time for t greater than 0, I guess. Yeah. Oops. Oh, wait a sec. We're making good time. I can probably actually finish by tonight, and then I have to immediately start cramming. Oh, kalite. It's still only Tuesday. Jeez. なんで逆なんだ。Let's see, so it should be c squared t squared plus b squared, or quantity, that quantity, minus in the top. Because in the original equation it is minus, fuck. Did I just copy it down backwards? I have E equals... They have a negative sign. Okay, so they are equivalent. So these signs, it does make sense for this to be flipped. No, it doesn't. Because then you get V minus C. Or you get V... Yeah, you get V minus C if you take out the minus sign. So... strange. Oh, I do have it backwards, fuck. Which I guess means I know what the solution to this part over here is now. I just don't know how you get it. Alright, this is more involved than I thought. Pasnik, if you're looking for cute Emma girl to cat MA voice, sorry to disappoint. If you get this, feel free to stay. I'm actually gonna go clean my my coffee mug real quick, so I'll be right back. Yeah, I left some coffee in there from this morning, and I was about to fill it up with something, but I didn't want, you know, there's like a coffee stain on it, and I don't want it to like be permanent. So sorry. And then I'll get back to studying. Actually, let me go to the bathroom too. Alright, let's get back to work. Right, so we figured out that we should be using the equation for... I can't talk. So we figured out that we were actually doing it backwards. What we really wanted was we want the equation for an electric field due to a moving point charge to the, or where the field point is to the left of the charge. That's actually the scenario. Yeah, the scenario that we have right now. So in this derivation, I'm still not quite sure what's wrong, but let's maybe make the setup a little more convenient for ourselves. So let's make this over here. So not only do we place the field point to the left of the origin, but we also place the, or not only do we, yeah, we also put the charge to the left of the origin. Yeah. I don't know why that should change anything, but it should change a sign or two. Cool. And then this entire length is now script r, which is equal to r minus, or r minus w, which is equal to negative rx plus wx, which is negative r minus w x hat vector. Yeah. And then I feel like I should be able to then say that oh, mixed up. Cool, 2 minutes. All right. So script R really shouldn't change. So this implies that script R left, or so script R left, the magnitude is equal to square root the square of r minus w x hat quantity squared, which is equal to r minus w, which equals script hat right. So we should be able to do that calculation and just swap those in. The only real change is where v comes into play. How did we calculate v initially? V pops up in beta calculations, and V is determined by well, actually, wait, we can just do this by observation too. We can say that likewise, wt equals negative wx hat, w dot t equals negative w dot x hat, which is equal to, or sorry, dot hat, which is equal to v left, which is equal to negative v Right. So therefore, we can assume that these are the solutions. Actually, let's do it like this. This is in proof, so we keep it minus plus. Script our hat. Cool. And we get rid of all this work. Don't think it's been 2 minutes yet. Right, so then in part 3, what we should actually be quoting for the electric field is part 2b's answer. Yeah, so what we should be saying is Q1, the stationary charge, or the field point, is to the left of Q2. So therefore from 2b, we should be quoting the other equation. Yeah, okay, cool. And then we get our negative sign. This derivation is the same, this derivation is the same, this part is the same, and this part changes. So we have a negative and a positive, negative and a positive, negative and positive, negative and positive, and a negative and a positive, which then changes these values. This is a negative positive and then a positive negative, which means that these two cancel and these two cancel. Which means that we have c b squared over c cubed t squared equals b squared over c squared t squared. Okay. And then the electric field, yeah, okay. Alright, so the whole equation is therefore equal to, what form do they use? Okay, there's no more cancellation, okay. q over 4 pi epsilon naught 4 c squared t squared over c squared t squared plus b squared, quantity squared, why are these multiplied? Because I'm stupid and added plus sign. There we go. B squared over c squared t squared. These, yeah, I don't know where the plus sign came from. It just got mixed in there at some point. That's fine. Cool. So that's for the electric field. And for the magnetic field, we say that that is 1 over c script r hat ret cross e, which is equal to 1 over c x hat cross stuff. Well, I can copy paste it. It's fine. Copy and iOS gestures, which equals 0. Cool. So then Lorentz force law, we can say F of charge 2 applying force on charge 1 is equal to Q, I guess 2. Times Q over 4 pi epsilon naught. I just copy this. Sorry. E. How do I know which charge I'm working with here? E is Q2. E is Q2, that makes sense because E is the field at the origin caused by charge 2, yeah. E T ret is caused by Q2, therefore Q equals Q2 in this case. And this derivation still happens. Then the force of Q2 on Q1 is Q1 times the electric field on it plus V cross B, which is 0. Therefore, the force of Q2 on Q1 is equal to Q1 Q2 over 4 pi epsilon naught, all the other crap. And then when Q2 is visible to Q1. Which is after t equals 0. Cool. And then lastly, part 3f. What is the total momentum? I1 is equal to the infinite integral of f1 of t dt delivered to q1 by q2. It's nice of them to just give us the integral. Of course, it's a massive thing, so maybe it's not that nice. Okay. dt. They say it's negative. Did I miss the negative sign? Alright, this tea should be good. Watch out. Watch out. Trader Joe's Sencha. Tastes good. Tastes fine. No complaints whatsoever. Right. Alright, so let's try it. Q1 over Q2, 4 pi epsilon naught. We don't need to worry about 4c squared b squared, nor do we really care. Actually, those cancel. Anyway, nor do we care about the c squared in the denominator, negative infinity to infinity of t squared over c squared t squared plus b squared, quantity squared, times t squared. Those two cancel. So we really just care about the integral of 1 over c squared t squared plus b squared, quantity squared dt. I don't actually know how to do this one. I don't really know how to do any of the integrals, honestly. So it's 1 over, I guess, ax squared plus b, I guess, and then quantity squared. Okay, it's not like I'm gonna be able to do it. Let me just, let's see. Integral. I'll actually learn it this way instead of just doing bullshit math. 1 over quantity squared, and then inside that quantity, ax squared plus b squared. Yeah, 1 over ax, or quantity ax squared plus b squared, total denominator squared. Yes. And what is the integral? Please be clean. We have an arctan, which is okay because we have infinities. And we do end up with a pi. Yeah, so I guess that's fine. I actually really don't want to do that integration, so let me see if I can I can quote like an integral table or something. So it's ax squared plus, or ax quantity squared plus b squared total quantity squared, or 1 over that. 1 over oh, I see. You can make it a little better. or at least easier to Google. You can take out c squared. Yeah. So you take out 1 over c to the 4th. And then you can still do the integral, but now it's easier to find. T squared plus b squared over c squared total quantity squared dt. I think. C to the 4th, yeah.正直疲れた。そういうこと？はい。Oh, I had my model off the entire time. Durr. Anyway. Okay. So yeah, now we can just look up the integral for a squared, or sorry, x squared plus a squared quantity squared. Or some general form, maybe. There's some like brain dead derivation that I'm not thinking of. Let's see. 1 over total quantity squared x squared plus a squared. Yeah, you still end up with arctan. No idea how to do this fucking integral. Oh wait, they restricted to 0 to infinity. Why is that? Oh, because it's it's because the particle isn't visible to the moving particle is invisible to the stationary particle until t equals 0. And the rest is the same. Almost there. Just need to be able to do this integral. You know what? Let's see. How much do they really care about this? Let me look on Piazza. Did the professor really want us to grind out this integral? If not, I really just want to quote Wolfram Alpha or something. What am I starting right now? EM, or sorry, electromagnetism and optics. Well, I mean, it's second semester EM, off of the Griffiths Intro to Electrodynamics textbook. So right now the actual topic is fields, so electric and magnetic fields generated from a moving point charge. And I'm almost there. I almost have the answer. It's just there's this one annoying integral that I don't really know how to do. One of yours classes, well, I mean, I'm retaking this, so I can certainly relate. Yeah, I took it last semester, and it's kind of, I need it for upper division physics elective in order to graduate, but yeah, I had a lot going on last semester, so something had to give. But anyway, I'm doing better this semester, but I do just want to finish this up and then honestly go to sleep. Yeah. That, and I can I just can't study as quickly as they usually give numbers that usually you, for every hour of lecture you study 2 or 3 hours or something, right? And then some extra number of hours for problem sets or something. But But for me, it takes more like 6 hours per hour of lecture, if not more. So it's kind of like, everything just takes longer. So, but since this is the only class I'm taking this semester, you would hope it'd go better, right? Yeah. But anyway, yeah, it's no, that right. It is what it is, right? Just sometimes you just gotta brute force, just dump more time into it. Yeah. Although I'm very tempted to just kind of quote Wolfram Alpha for the result of the integral. It is, yeah, it is what it is. Because I was hoping there would be an integral table that maybe listed it, but I don't see anything. What kind of integral? It's 1 over I guess 1 over x squared plus a squared quantity squared, which I thought would be really straightforward. Sorry, I can type it in chat. But the entire denominator is it's the sum of squares and then you square the sum of squares is the point. But it's this form, which I don't know. I was expecting it to be easy, but I shoved it into Wolfram Alpha because I couldn't figure it out, and it looks more involved than I was expecting. Yeah. Yeah. Yeah, fine. I'll just. Thankfully, Integral Calculator has all the steps, so I guess I just have to suck it up and just interpret it, or I guess relearn it. Reduction. Okay. And the fact that this came up in the homework probably means it might pop up in an example. So I guess it's probably good to have all the steps written down somewhere. Yeah, internet calculator. I get it. It'd be nice to be able to do this on your own, but my calc grade was honestly not that good, and I think my time would be better spent actually learning the material than trying to grind out one integral. Let's see. Ax squared plus b. Oh, you rewrite the entire integral as... Huh. And then I go... Okay, so they just split it up into... Or no, they don't. Sorry, let me see. So, reduction formula. You know what? At this point, again, I don't want to... It's almost 11 o'clock. I want to go to sleep. I'm just going to... If I lose points for that part, then fine. And then I'll just keep a memo to myself to actually look up the derivation. Come exam time. Right, how to resolve it. It bothers me, right? It bothers me. I tried to do it, I tried to solve it manually, but I was like, I'm not gonna spend, I mean, I can. I'd like to at some point. I would like for that time to not be now, yeah. Although, actually, wait, sorry. I think there was a... Was I missing a minus sign earlier somewhere? I don't know. But, yeah, I don't know. You know, it's one of those things where like I feel like for every semester I take courses, you know, I feel like, oh, you know, it'd be nice to go back and like go back to like, I don't know, middle school math and just relearn everything again. But three, oh yeah, sounds good. Thanks for popping by. Take care, stay safe, have a good evening, and yeah, see you around. What's got it? Where's me? And I'm just going to quote the answer. Let's see. Integral calculus. I mean, you know, like at this point, I mean, I'll go back to like pre-cal and everything, and like even freaking geometry, because I feel like some of my trig is like, you know, wrong sometimes. So it's like, yeah, I feel like every single, you know, yeah, just it'd be nice to just go back and learn everything again now that, you know, I've seen it a little bit. Yeah. But yeah, anyway, let's say, yeah, I'll let you go now. Thanks for popping by. I'm gonna finish this up and I'm gonna sleep too. So yeah, but yeah, let's go to where's me? Let's see. So arctan of let me write the full integral. It's 1 over 1 over x squared plus a squared. Integral dx equals arctan x over a over 2a cubed plus x over okay. All right. And then we want to evaluate this from 0 to infinity. Well, that's a problem. Oh, but you can say this scales as 1 over t. So this term should go to 0. be pi over 2. Yeah. So we get pi over 2 over 2b cubed over c cubed. There's 1 over c to the 4th that got pulled out. Ah, and the 4 cancels. Okay. So c squareds cancel. This cancels with most of the c's. B squared cancels with most of those. And these 2's cancel with this 4. So you end up with q1, q2 over 4 pi epsilon naught pi over cb. Is that right? q1, q2 over negative. Where did I lose the negative sign? Let's see. So if the 4th should have been negative. Is the electric field negative? Yes, it is. Where did I miss that term? Script r squared shouldn't generate any negatives. Those should just be negative signs. I don't know. Okay, I don't know where the minus sign went, and I'm honestly too tired to care. Actually, I probably should turn off the screen. Are these homeworks or are these problem sets? Alright, and then hopefully the GSI takes the problem set. If not, it's okay because, well, I'll probably need it for the exam anyway. So I'm too tired. I'm done. So everyone that came by, thanks for coming by. Take care, stay safe, have a good evening. I wanted to go home today, but it's honestly kind of late, so I'll probably just sleep in the office again. Ugh. But anyway, yeah, thanks for coming by. Take care, stay safe, have a good evening. I can show the screen now. See you guys later. お疲れ、おやすみ、終わり。